We're on number 9. All right, let me get all the colors situated here. Let's go green. Yes, sir. All right. So RT, we did that ratio, didn't we? To find RT, we did the whole bottom to the whole. So we took the whole bottom of the big one to the whole bottom of the little one. We had the whole right side of the big one to the whole right side of the little one, right? Cross multiply, blah, 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 and we found it, okay? So SV, we need to find SV. Well, we found the, let's use that same scale factor. So what would the scale factor be? Actually, watch this. To do the sides, we don't have to compare the whole entire side. If we're going to compare, like, this is a little too small. Let's blow this up a little bit so I can blow it up. There we go. This is 7. I passed it out yesterday. You didn't get it yesterday? You didn't? Oh, well, there's probably one up there on that pile. So let's do this. Let's find SV. What we can do is, let's do the scale factor like this. Let's make this a little bit smaller. 0.75. There we go. All right, so let's compare it like this. If I have two parallel lines in this triangle like this, I can compare this one to this one, and what? 15 to this 7x minus 9, and that's what I would do right there. So what is the scale factor? Just in your head, what 12 to 24, what would it be? It's 1 to 2, right? So if we go 1 to 2, that means what? This is twice as big as this, isn't it? I mean, you could set the whole thing up, but I'm just trying to get my head around it. So since it's really easy, since this segment is twice as big as this one has to be twice as big as this one. That's right. So you could just go 7x minus 9 equals 30. Because it would eventually end up that way anyway, wouldn't it? Because if I do this, 12 to 24, 1 to 2, what would this be? 15 to what? 7x minus 9. If you cross multiplied, guess what you would get? You would get that exact same thing, wouldn't you? Does that make sense? All right. So, I mean, yeah, you could have done that. That'd been fine. But you could have also realized, since it was an easy scale factor, this was twice as big as this. You could just say, oh, that's twice as big as that, so this must be 30. And then you just do the math. That's, what, 39 over 7, right? And then it doesn't really reduce, so just keep it like that. 39 over 7. Everybody got that? Good. Let's move on. Let's look at this one. Oh, these are real super easy, aren't they? Find LM. So let's do this. Let's find out which numbers correspond to what. These are parallel to each other, right? So this must equal this. If you want to put some equal angles, just so you know which ones match up. It's pretty obvious. All right, I made it super, super easy because I didn't put any other sides on there. So the 18 and 12 pretty much have to be the ones that correspond to each other, wouldn't you think? But how do we know for sure? Because 18 is opposite the angle with 2 arcs, 12 is opposite the angle with 2 arcs. So let's do that. So 18 to 12. That's our scale factor. We could reduce it. What goes into both of those? 6, 3 times, 2 times, so 3 to 2. That's our scale factor. So what are we going to compare? We compared the big one to the smaller one, so we're going, or the left one to the right one. So we're going to compare what? X plus 3 to x minus 1. Would you agree? Just for the sake of time, I don't need to go through this math, do I? Just make sure you do what? Distribute, right? Distribute that 3, distribute the 2, solve for x. But that's not your answer, though. Once you get x, you have to add it to the 3, and then you can get ln. Make sure you do that. Make sure you don't just get x and think, woohoo, I'm done. I got x. All right, now I'm finished. No. Sometimes that's true. Sometimes all you have to do is solve for x. But sometimes you got to plug it back in and solve for that line segment. Make sense? All right, QP. So, look, you already found what x was. What was x when you did this? Anybody have it? Nobody? Oh, whatever. Whatever x is, you put it in here. And then what do you do for QP? You just take 1 away from that x. Okay, it was just as easy. So if you didn't get the right x, you missed both of those, didn't you? Right? If you didn't get the right x. So it's very important that you get x to be correct there. All right, let's go to this one. Ooh, let's make that a little bit smaller. All right, so here we go. Let's change colors. I'm tired of that green already. Let's go to this color. Let's see. Determine so that these are parallel. It doesn't say they're parallel. We want to figure out if they're parallel, or what should x equal in order for these two lines to be parallel. It's basically the same kind of problem as what we just did before. It's just the converse of it. That's all. So let's put some numbers in. XL is 3. YM is 5. LD is 9. Yep. Well, yeah, determine the value of x, exactly. So on these, you actually are just finding x. So once you get x, what do you do after you get x? Woohoo, right? Isn't that what I said? All right, so yeah, you could set up your ratio, or this is another easy, simple ratio. Watch, this is 3 to 9, or 1 to 3, right? So this is 3 times as big as this. So what's x plus 3? It's 3 times as big as this, so it's got to be 15. X plus 3 is 15. Subtract 3 from both sides. X is 12. Simple as that. Make sense? All right. I'm just trying to go quickly, right? Because, you only have a certain amount of time, and the faster you do things, it's not always the best, but yep. Is that the answer? Does anybody have the test in front of them? Just make sure I'm saying the right answers. Okay. All right, so that was 12. Let's do 13. YM is 3. LD is 3x plus 1. Yeah, that's fine. XL is 4, that little bit right there. And MD is x plus 7. All right, so here's your scale factor. Scale factor, I would go 4 to 3, wouldn't you? All right. Now, this is not quite as easy as 1 to 3 or 1 to 2, so we'll write out the whole scale factor on this. So you could do it a couple ways. You could compare this one to this one, and then what would you have to do? Compare this to this. Or you could go 4 to this one, right? Top left to bottom left, top right to bottom right. You can do it any way that you want to. So let's just set it up, and I'll let you do the math yourself. How do you want to set it up? 4 to 3?
4 to 3.
All right. So if I go 4 to 3, then I'm going to have to go 3x plus 1 to x plus 7. And then you cross multiply and you solve for x, and you're actually finished then, aren't you? Because it just says find the value of x. Everybody's okay with this part, right? Cross multiplying, I don't think I have to go through that. Good. Again, you can check your answers on your original test, because even if you got it wrong the second time around, I wrote down what the correct answer was, so you should all have the answers in front of you. Let's do this one. This is getting a little old, and MD is 5x minus 6. This is the same setup. YM is 3. LD is 5x plus 1. And then XL is 5. Yeah, it's the same exact thing. I don't have to go through this, do I? 5 to 3, 5x plus 1 over 5x minus 6, cross multiply, solve for x, and you're done. They're kind of like all three identical problems, just different numbers. I probably should switch that up next year, shouldn't I? Because it's a little too monotonous. All right, what about this? What about 15? Well, I'm talking about me.
16,
For the clones. Oh, for the ones that said no, right? Yeah. I don't know. Maybe some people in here are going to take it again. All right, let's do this. What do we find x and y? Oh my goodness, this is way too easy. Man, I made this test too easy. I should have made this harder, shouldn't I? All right. I should make the I could make the final a lot harder. Maybe I can make it a lot
How
harder.
many tests are? I mean, how many questions are?
All right, I'm just kidding. Come on, what do we do? You got to solve for x. Look, this segment and this segment are equal, so you just set them equal. Let's do the math. I know you guys hate fractions.
Did well.
Oh, why did I put plus? Equals 1/5 x plus 3. All right, here we go. So how do you solve for this with a fraction? Let's go through it real quick. I'm going to subtract a 1/5 x, correct, from this. So you could say like 3 4/5, but I wouldn't do that. Okay, that's too complicated. I don't know. Maybe you
Not
think
really.
this is too complicated. How would I? Yeah, make it improper. How would I write 4 with a denominator of 5? What would that be? That'd be 20 over 5, wouldn't it? Okay. So what's 20 over 5 minus 1 over 5? It's 19 over 5. I think that's the best way to do it, don't you? I'd much rather do that than I would using mixed numbers. And then add a 35, which gives 38. How do you get rid of a fraction? See, this is way, way better than having a mixed number here. multiplied by the reciprocal. That's right. So that'll go away. Well, it's the same thing, basically. All right. Look, this is rigged. That goes into that twice. So x is 10. So x is 10. Why is that funny? You've never heard that?
It's math. You're like,
Nuh-uh. He did. There you go. Eyeballing it. Whoops. Thicker. See, you did
we have
learn.
math
See, you
jokes?
did
That
learn.
is so sad.
See,
We
you got
have
math jokes. See?
I have a study sheet for math. It's like a straight line formula, and I'm like, all lines are straight. There's not like a.
There you go. That's right. It's redundant, isn't it, to say a straight line? Because you're right. I'm not even going to bother doing this one. Because what do you do with that? Set them equal to each other, solve for y. No big deal. Yes, that's way too easy. Oh, I'm so embarrassed. I can't believe the world is looking at this and knowing that I gave this on a test.
No, we did that yesterday. So.
The whole world, all 3 people will be watching this video. All right, what about this thing right here? This one's not quite as easy,
Can
so
they hear
that's
what I'm
good.
saying?
I didn't hear what.
Can they hear what I'm saying?
Yeah, probably. Yeah. Yeah, the whole world can hear you. Yes. Is it easy? Okay, good.
Because we are pretty close.
Well, my goodness, you're right. This is an easy one. My goodness, I gotta rethink this test.
I got a
Everybody must have got 100 on this test, right?
I got a 94.
So watch. So you got to find WX. You're absolutely right. This is an isosceles triangle, and this angle is being bisected. So actually, this hits how? This hits perpendicular, and it bisects that segment right there, that third
I got a
side,
98 on this one.
right? Now, if I make those two the same, now if I made them different, you'd have to set up a ratio, and you could call one x, and what would I call this? If I called this x, 28 minus x. Okay, so if I had this like 15 or something like that, you would have to set up a ratio. That's the way I should have made this problem, but I made this way too easy. My goodness, I must have been in
Didn't
a
you have to do math?
good mood or something. Right, so it's just 14, right? And what? YW?
14.
Oh
Both
my
14.
goodness. Jeez. I'm so embarrassed. I apologize. Yeah, I
He's
apologize.
embarrassed.
I am.
How easy he made it.
I am. It is embarrassing. I should have made that a lot harder. I should make a mental note to change that test up next year. What about this one? The length of a scale model is 9. Oh, this one, this threw people for a loop. I remember this one. 9 what? Inches, and the actual length is what?
150
Feet. So I can't compare inches to feet. I'm going to have to change one to the other, okay? You want to change 150 feet to inches? So what would I do with that 150 feet? Right, times it by 12, and so 150, oops, yeah, oops, 150, what is it, 1800? Okay, times 12, let me just do it since I'm in the middle of it. What's going on here with my calculator? What? It's freaking out. 150 times 12, yeah, it's the heat, 1800. No, everybody in my other class was crying because it was so cold in here. I love it. Doesn't it feel good? I love it. It's just crisp. It makes you feel alive. I love it. So what is it? 1,800 inches, right? So watch. The scale model is what? It's 9 inches to what? 1,800 what? Inches. I can't compare 9 inches to 150 feet. Okay, I can't get a scale factor like that. Look what happens to the inches. Cancel out. Scale factor doesn't have any dimensions to it, right? For instance, remember that one easy scale factor was 1 to 2? That means that one side is twice as big as the other side. Does it matter if it's 2 feet, 2 inches, 2 whatever? No, it's just twice as big. So what is this? 9 goes into 9 once. 9 goes into 18, what? Twice. So what is it? 1 over what? 200. And that is the ratio, the scale factor of the model. All right? Yeah, so for every 1 inch you go on the model, you're going to go 200 inches on the actual real length ship. Okay? All right, what about this one? Yeah. Mm-hmm. Yeah, I think I gave it to you because you kept it inches and feet, but technically, and because I remember thinking about that and thinking, that's not what I wanted, but I didn't really specify, and technically it would be the scale factor, but it's really better to write it like this. The scale factor shouldn't. Yeah, let's say on the final, since I'm saying it now, yes, I want it like this. If in all the same dimension, because look, if I would have changed this to feet, it would have still come out to the same exact thing. You don't believe me? So what would 9 inches be?
No, we believe you. Nobody said they didn't
What?
believe you. We all believe you. We all believe you. We promise.
So what?
Let's
It's
go through our honesty.
oh goodness. See, we were gonna have some fun with that and show you it was gonna come out to the same thing. Just you guys are
You'll be like, oh, you asked.
guys are
Okay.
party
We
poopers.
didn't ask you.
You guys don't believe me? No, we believe you.
You guys are party poopers. Okay, here we go.
Definitely believe you.
Watch, 15-foot tall wall casts a shadow 20 feet. We've done these things before, right? Here's the wall, 15 feet, 20 feet.
It's so easy. You
Okay.
just put it in proportions.
And then it says a building. Oh, I should have done that differently. Let's say that's the building. Okay, this is the building. Oh, wait, no. Yeah. Right, I know. The building's taller, isn't it? Yep, this is the building, so we'll call that H for height. That's the building, okay? And that's the shadow, 32 feet from here to here. Agreed? All right. And then there's a wall that casts a 20-foot shadow, 15-foot wall. So if it only casts a 20-foot shadow, it must be a shorter than the building. Would you agree? If it casts a shorter shadow? Yes. So here's the wall, and it's 15 feet, and it casts a 20-foot shadow. Got it? And so these are proportional, okay, scale factor and all that kind of stuff. We won't go through all the reasoning behind it. Let's just do it. So what can I compare? If you compare H to 15, which is perfectly fine, watch, if I go H to 15, you got to be careful with this though. This is the whole entire left side of the big triangle, correct? I'm comparing it to the whole entire left side of the little triangle. So what am I going to have to compare? 32. Oh, I made this way too easy too, didn't I? Okay, 32, which is the whole bottom of the big triangle, to the whole bottom of the little triangle, which is 20. And then you can cross multiply, or you can just do what? Multiply by 15, and then plug it in. Boom, you got it. Everybody good? Yes. Minus 2ab cosine c. It's not plus. That's the law of cosines. Yeah. If you have a problem with the law of cosines, sure you will.
Wait, what was
We haven't got to that. That was chapter 8. That's the next test. We just finished 7.
Chapter 8 sucks.
We just finished 7. So let me stop this and I'll start a new video for chapter 8.